In this video, we are going to do an improper integral that goes from negative infinity to positive infinity. So let's get right into an example. So I want to determine whether this improper integral that goes from negative infinity to positive infinity converges or if it diverges. And if it does converge, then evaluate it. So first, I want to notice that what makes this improper is the fact that this interval is infinitely long. We've seen that when we have an integral that involves an infinity and a negative infinity, we have to handle the infinities kind of one at a time. So I'm first going to need to split this integral up into two pieces. The first, that goes from negative infinity to some number, and I'll just put an empty box there, of my function, 12x to the third, all over that x to the fourth plus 2 getting cubed, dx. And then plus another integral that's going to pick up where the last one left off. So I'll put an empty box up until infinity. And then that same function, 12x to the third, all over x to the 4 plus 2, that getting cubed, dx. So what goes in the box in these two spots? Well, we could pick any number as long as we pick the same thing in both of those spots. So we could pick any number here as long as we do the same thing in both of those spots. So for convenience, I'm going to just do something small and simple. I'm going to just put 0 in both of those spots. Just because later when I got to plug in, it's typically quite nice to plug in 0. So now I got to do both of these integrals. I got to do this one, this first one. I got to do this integral over here. I also got to do this second one. So they're really similar in how we work them out. So I'm going to pick one of them to do and work it out, and then I'll just tell you what we end up getting if we were to do the other one. So let's do this second one first. Let's do this. But they're really similar. Let's do this first. Doesn't really matter which one I do first. I'm just going to pick that one. So to do that integral, I first want to have you pause the video to think about how you might do that integral. So pause it for 2 minutes to think about what method do I use? U sub, integration by parts, something else. Pause it in 3, 2, 1, and try it. All right, so hopefully you did that. Hopefully you paused it and tried it. Let's talk about it now. So it turns out that we can handle this with a U sub. We can do this with a U sub. And I let u be the inside stuff in the parentheses, x to the 4 plus 2. Because then du is going to be 4x to the 3 dx. And the way I can tell that this u sub is going to work is ignoring this constant multiple, this 4, I see this function x to the 3 dx in my integral. Because I see it right here, x to the 3 dx. And in both spots, like the x to the third, this is in the numerator. Just like in du, x to the third is in the numerator. So the fact that those are matching indicates, okay, this is a good choice for this u sub. All right, so what can I do now? So let's see. There's a couple ways I can handle this, but one is I can isolate dx and say, okay, du over 4x to the third is going to be equal to dx. Now let's go and let's start to set up our integral. So remember that when I have one of these improper integrals, well, that bottom number was a 0. When I have an infinity, I'm going to replace it with a t. I'm going to replace it with a variable like t. And then inside the function, I have 12x to the third on top. On the bottom, when I sub in, I get u cubed. And then dx, well, I know that dx is du over 4x to the third. One thing I got to do with this is I got to keep in mind that these limits of integration are in terms of the original variable. And when I start to do a u sub, I either have to convert these to be in terms of the new variable u, using the u sub, or if I decide not to do that, I could keep them as they are, and later, once I do my antiderivative, sub back in for x, so I can plug in these x values. But if I do that to avoid confusion about what are these x's or u's, I should specify what they are. So these are x values. So I should write x equals 0 and x equals t. So now, simplifying this, I get some cancellation. The 12 over 4 becomes a 3, and I can pull that in front of the integral. I get x equals 0 up until x equals t. The x to the thirds also cancel, and then I can move u to the 3 up, so u to the negative 3 du. That's something we can do the antiderivative of. So I can do a reverse power rule on that. That'll give me 3 u to the negative 2 over negative 2. Vertical line, I got to plug in x equals 0 and x equals t. Now, let's simplify this a little bit. So I'll move that u to the negative 2 to the denominator to make it a positive exponent. And then let's also sub back in for what u equals. So I get a minus in front. I can pull that negative to the front. 3 all over 2, and it's u squared, but let's sub back in for u, because u is x to the 4 plus 2. That's getting squared. Now that I've subbed back in, and this function's completely in terms of x, now this ambiguity about, well, all these limits of integration, x values or u values, now that's gone. So now I can just write 0 and t again. I don't have to say x equals anymore. All right. So we got this. Now we're going to be ready to plug in the t and the 0 and subtract. And then, because this is an improper integral, I got to do a limit now. So let us add that limit in front. Limit. And what's t approaching here? For this limit, t is approaching infinity. T is approaching infinity, and that, let's plug in. If I plug in t, I'm going to get minus 3 all over 2 parentheses. T to the 4th, so I'm plugging in t. T to the 4th plus 2, that is getting squared. And then I'll get minus, I'll put a parentheses. When I plug in 0, I get negative 3 over, and then 2 parentheses. If I plug 0 into the parentheses, I'll get just 2, and that's getting squared. All right. So now, okay, close that bracket that I started. Now let's plug infinity into this. So this first fraction becomes, I got a minus 3 all over. The denominator will end up being infinity once I plug it in. And then that second term, well, a double negative becomes a positive, and I get 3 over 8. So negative 3 over infinity, well, that's approaching 0. So I get 0 plus 3 over 8, which is 3 over 8. So nice. We just found the value of this second integral. It turns out, let's highlight this. I've been highlighting it in orange. So it's just 3 over 8. So if I can figure out the value of this first integral, I just add that to the 3 over 8, and I'll get my final answer. I mentioned at the start that both of these integrals are going to be very, very similar. It's the exact same function, so it'll be the exact same u sub that I end up doing, except, you know, the limits of integration are different. That's all that's going to be different about it. So I'm going to skip doing the actual integral. I'll just tell you what you end up getting. It turns out that this one is actually negative 3 over 8. And I was highlighting that one in blue at the beginning, so I'll highlight this value in blue, negative 3 over 8. So that means for my initial problem, the integral from negative infinity to positive infinity of this function, which we split up into these two pieces, well, now we know what each of those two pieces is. This first integral was negative 3/8. The other one was positive 3/8. The other one was positive 3/8. I just want to make sure that I did it in the right order. Did I? The one from negative infinity to 0, that's negative 3/8. Yep. And the one from 0 to infinity, that's the one that we did up here. That's positive 3/8. Yep. Okay, and then adding those together, we get 0. Okay, so nice. Okay, so the overall value of this integral is 0. It does converge. So it said determine if it converges or not. It does converge because I got a finite value, and it converges to 0. Nice. So the follow-up question I want to ask now is, so in this problem, we had this doubly infinite integral. There were two infinities here, negative and positive. Could I do this by just replacing both of them, like one of them with a minus t at the bottom and then t at the top, and then just doing the limit as t goes to infinity? Like, could I handle both of those at the same time like this? It turns out the answer to that is no, and we will see why in the homework. So we're going to investigate why this is in the homework. Okay, so keep a lookout for that. There's going to be a homework problem about that where we kind of explore why that is. So I want to end with some takeaways about problems like this, where you have an integral from negative infinity to positive infinity. If both of these pieces, once I split it up, end up converging. So let me say it like this. I need both of those pieces to converge in order for my original integral to converge. In order for that original one to converge. But on the other hand, if either one of these pieces diverges, if even one of them diverges, then that original integral diverges. Okay, so that is something to look out for. In the later videos in the section, there's going to be at least one more example that we do where I have to split up an integral into multiple pieces. And if either one of those pieces diverges, we're done. We can say that the original one diverges.